Kinetic friction versus static friction. Friction is the force exerted by a surface as an object moves across it or attempts to move across it. There are two kinds of friction, static friction and kinetic friction. Static friction is the force present before the object in contact with the surface actually begins to move. As I stand on my snowboard at the top of the mountain, there's static friction between my board and the snow before I begin to slide. Once I begin to slide and am moving, the force present between the snow and my snowboard is kinetic friction. The force of friction varies depending on the two objects that are rubbing together. In the case of snowboarding, less friction is ideal. People coat their snowboards in wax to reduce friction between the snow and their board, which allows them to slide down the hill faster.
Snowboarding is a good example of static friction and kinetic friction. Right now, here at the top of the mountain, there's static friction between my snowboard and the snow. As soon as I start sliding down the hill, it's kinetic friction between my snowboard and the snow. This is static friction, it's holding me in place, and as soon as I start to slide down the hill, it's becoming kinetic friction. All kinetic friction, the snow and my snowboard. My snowboard has wax all over the bottom of it in order to enable the board to slide with less friction down the hill. This is a good example of kinetic friction between my snowboard and the snow.
Newton's first law of motion states a body at rest remains at rest, and a body in motion remains in motion with a constant speed and in a straight line unless acted upon by unbalanced forces. As I stand and dribble the ball, it moves in the direction that my hand is applying the force. My hand is applying an unbalanced force, so the ball is not moving at a constant speed, but will continue moving in a straight line until another force acts on it. In this case, the floor is the next force to act on the ball. This is also an example of Newton's third law that states if an object A exerts a force on object B exerts a force on object A with the same strength but in the opposite direction. The ball exerts a force on the floor, and the floor exerts an equal and opposite force.
Work versus energy. Sound energy is causing the paper over the speaker to move. The energy is transformed from sound energy to kinetic energy. Energy is not the same thing as work. Although an activity may require energy, it doesn't mean you've done any work by physics standards. In order for it to be work, the object must be moved. Work equals force times distance. Because the paper is moving, the sound energy has done work on the paper.
A force is a push or pull applied to an object. Torque is a type of force. It is a twisting force that generally causes rotation. Stretched out, I have a big momentum of inertia. This means it requires a larger torque to make me rotate. When I tuck in, I have a smaller moment of inertia. I require less torque to rotate and spin much faster.